It's easy to assume that number 4 may be the easiest of the 4, but it's actually, there's a little more work than problems 1, 2, and 3. Let's first start by rewriting this in vertex form. And I'm going to do that down here. So I'm going to add 3 to the opposite side to get x plus 3 equals x squared plus x plus this missing value. Now the great thing here is that the leading coefficient is 1. I don't need to factor anything out. The tough thing is when you take this b value, which is a hidden 1, and I divide it by 2 and then square it, well, 1 over 2 times 1 over 2, because that's what 1/2 squared means, would give you 1 over 4. So 1 over 4 goes into this position. I added 1/4 to the right. I must add 1/4, sorry, it's a plus sign. I must add 1/4 to the left. So when I factor this, I have x. This is what goes in this position, plus 1/2 quantity squared. Now I need to combine a 3 and a 1/4. So 3 over 1 plus 1/4. Let's get a common denominator. Let me zoom this out so you can see. I'm going to go times 4 and times 4 to get 12 over 4 plus 1 over 4, which is 13 over 4. So this is y plus 13 over 4. Now I'm going to move 13 over 4 back to the opposite side. It is positive. When it moves over, we can see that it is then negative. This is in vertex form. I'm going to grab the calculator, erase the 2 previous problems I had in. I'm going to start by putting in what we have provided in standard form. So x squared plus x minus 3, I graph it. I come back and I'm going to type in quantity x plus 1/2, or I could do 0.5, quantity squared minus, in parentheses, 13 divided by 4. And we can see they're the exact same thing. And you may say to yourself, like, that's not what the answer key says. It just took this and it put it into mixed number form. So it went, how many groups of 4 fit into 13? 3 groups. So I'd have 3 and 1/4. That's what's equivalent to this. I would accept either one. I just know writing 3 and 1/4 here is not possible. So I kept it in proper form. You can do the same. What is the vertex? The vertex is negative 1/2. And it is negative 13 over 4. So I'm going to graph, I'm thinking this in my head, of negative 0.5, if that helps us. And 13 and 1/4 would be 3.25. And if you weren't sure about that, you could come over here and go 13 divided by 4. Okay, 3.25. All right. Again, it is a negative 3.25. And it is a negative 0.5. So I'm going to first start by graphing that here. It's going to be just an estimation. I'm going over half and down 3.5, 1, 2, 3, 3.25. So right about there. I can see that negative 3 is the y-intercept, so I do need to write that down. The y-intercept is 0 and negative 3. Now how do we identify what the x-intercepts are? Most people are going to come up here and they're just going to choose to use the quadratic formula. There is nothing wrong with that. In fact, I think in this situation it's probably easiest, so I'm going to do that. So x equals negative b, so my b is a positive 1, so negative 1 plus or minus, then it's going to be b squared minus 4ac all over 2 times a. So x equals negative 1 plus or minus, this is 1, okay, negative 4 times 1 times negative 3, this is a positive 12. 1 plus positive 12 is 13, and this is what I have now for my x-intercepts. Now, how do we go about graphing this? Well, remember we have 0, 0, 1, 1, 2, 4. Then we have negative 1, 1, and negative 2, 4. And our leading coefficient is a 1. So I can start from this point. I'm going to go, this is 0, 0. This is your vertex. I'm going to go 1 to the right and 1 up. So from here, 1 to the right and 1 up. And I'm going to go 2 to the right and 4 up. So to the right, 1, 2, and 4 up. 1, 2, 3, 4. And I'll do the same thing on the opposite side here. That's just approximation. I'm going to go 1 to the left and 1 up. 1 to the left and 1 up. And I'm going to go 2 to the left and 4 up. So 2 to the left, 1, 2, and 4 up.